Hello everyone, we will talk about electron spin resonance spectroscopy under supervision Professor Dr. Sami Abulwafa. Electron spin resonance ESR spectroscopy prepared by علاء هاني عبد المنعم، آية جمال عبد محمد، آية مدحت عبد الله، إيمان عاطف فتحي، فريال نصر الدين مصري، رنا عمري عبد الفتاح، نور إبراهيم محمد، أنسة عادل عبد الرازق under supervision Professor Dr. Sami Abulwafa. Electron spin resonance spectroscopy. Electron spin resonance ESR, also called electron paramagnetic resonance EPR spectroscopy, is a method for studying paramagnetic substances that exhibit characteristic magnetic properties. The electron spin resonance phenomenon is shown by atoms having an odd number of electrons, ions having partially filled inner energy levels, and molecules that carry angular momentum.
In this video, we will show how we can use ESR instruments.
The two coils making up the Helmholtz coil have to be connected with each other and the ESR operating unit. The coils are placed at a distance of 6.8 cm from each other. Then the resonance coil, which is used for the frequency range, is inserted into the LC circuit operating unit. Next, the sample has to be inserted into the resonance coil and the whole setup placed in between the Helmholtz coil. Connect the LC operating unit with the ESR operating unit and then connect the latter with the oscilloscope. Turn the knob on the side of the LC operating unit to achieve maximum gain to get a clear signal.
ESR spectroscopy uses mainly to study free radicals having unpaired electrons. These electrons remain after homolytic fission of a covalent bond by ultraviolet or gamma radiation. ESR and NMR. Electron spin resonance is another type of magnetic resonance that is connected with the magnetic behavior of spinning electrons. Both NMR and ESR spectroscopy are collectively showing the magnetic resonance phenomena, but NMR is observed in the radio frequency region and ESR is observed in microwave region of the electromagnetic spectrum. The theoretical principles of ESR and NMR are similar. Electron paramagnetic resonance EPR. Electron paramagnetic resonance EPR or electron spin resonance ESR spectroscopy is a method for studying materials that have unpaired electrons. The basic concepts of EPR are analogous to those nuclear magnetic resonance NMR, but the spins excited are those of electrons instead of atomic nuclei. EPR spectroscopy is particularly useful for studying material complexes and organic radicals. Although the equation permits a large combination of frequency and magnetic field values, the great majority of EPR measurements are made with microwaves in the 9000 to 10,000 MHz, 9 to 10 GHz region. EPR spectra can be generated mostly by keeping the photon frequency fixed. By increasing an external magnetic field, the gap between energy states is wind. The simplest case is for a species have one unpaired electron, S equal half. By analogy with NMR, the applications of an external magnetic field B0 produces a difference in energy between them, S equal positive half and ms equal negative half status of the electron. Delta E equal H multiply nu. It is a value for a free electron is 2.0023.
A phenol-based novel microcycle بين النيوكليي complemental legend NN-bis 26 diaminomethyl 4-methyl 1-hydroxyphenyl malonyl dicarboxamide was prepared. The complex were prepared by templates method by reacting 2,6-diformyl 4-methylphenol malonyl dihydroxide and the metal chloride of Cu2. Applications of ESR. EBR or ESR spectroscopy is used in various branches of science, such as biology, chemistry, and physics, for the detection and identification of free radical in solid, liquid, or gaseous state, and in paramagnetic centers such as F centers. Chemical, medical, geology.
Chemical reactions EBR is a sensitive specific method for studying both radicals formed chemical reactions and the reactions themselves. Such radicals can be identified and studied by EBR. Organic and inorganic radicals can be detected in electrochemical systems and in materials exposed to UV light. EBR spectroscopy is a particularly useful tool to investigate their electronic structures. Medical and biological applications of ESR also exist. They don't normally occur in high concentrations in biology. Special reagents have been developed to attach spin labels. Spin-labeled fatty acids have been extensively used to study dynamic organizations of lipids in biological membranes, lipid-protein interaction, and temperature of transition of gel to liquid crystalline phases. Material characterization EBR or ESR spectroscopy is used in geology and archaeology as dating tool. It can be applied to a wide range of material such as organic shales, carbonate, sulfate, phosphate, silica, or other silicates. When applied to shales, the EBR data correlate to the maturity of kerogen in the shale. EBR spectroscopy has been used to measure properties of crude oil, such as determination of asphaltene and vanadium content. The free radical component of EBR signal is proportional to the amount of asphaltene in the oil regardless of any solvent or precipitants that may be present in that oil. When the oil is subject to a precipitant such as hexane, heptane, pyridine, however, then much of the asphaltene can be subsequently extracted from the oil by gravimetric techniques. EBR has been used by archaeologists for dating of teeth. Radiation damage over long periods of time creates free radicals in tooth enamel which can then be examined by EBR and after proper calibration dates. Similarly, material extracted from the teeth of people during dental procedures can be used to quantify their cumulative exposure to ionizing radiation.
ESR questions. 1. Source used in ESR to produce monochromatic microwave is B. Nichrome wire, Q. RF oscillator, R. GaN oscillator, S. Silicon carbide rod, A. Q and R, B. B and S, C. R only, D. Q only. The answer is C. R only. 2. Unit for measurements of hyperfine splitting constant in ESR is A. Gauss, B. Tesla per second, C. C. Gauss per millimeter. D. No units. The answer is A. Gauss. 3. Which of the following electromagnetic radiation is used in ESR? A. IR radiation. B. Radio waves. C. X radiation. D. Microwave. The answer is D. Microwave. 4. Units for magnetic field strength are B. dBi, Q. Gauss, R. Tesla, S. Joule per radians. A. R and S. B. B and Q. C. Q and R. The answer is C. Q and R. 5. Which of the following will not show electron spin resonance ESR? A. Free radicals. B. Paramagnetic materials. C. Odd electrons, transition metals, ion. D. Diamagnetic materials. The answer is D. Diamagnetic materials. 6. Study of species having one or more unpaired electrons. A. ESR. B. EPR. C. IR. D. Both A and B. The answer is D. Both A and B. 7. Mounted along the E vector of the plane equal polarized microwave and produced a current proportional to the microwave power reflected from the cavity. A. Calomel electrode. B. Reference electrode. C. Membrane electrode. D. Diode electrode. The answer is D. Diode electrode. 8. All of the following is from NMR spectroscopy except A. Absorption position are expressed in terms of chemical shift. B. Absorption position are expressed in terms of G values. C. Nuclear spin coupling causes the splitting of signals. D. Different energy states are produced due to the alignment of the nuclear magnetic moment. The answer is B. Absorption position are expressed in terms of G values. Number 9. Which of the following will show electron spin resonance ESR spectrum? H2, Na positive, Cu positive, H. The answer is D, H. 10. Square planar complexes has 2 signals, 3 signals, 1 signals, 4 signals. The answer is C, 1 signals. 11. What is the another name of electron spin resonance ESR? Electron paramagnetic response. B. Electron-proton resonance. C. Electron paramagnetic reoccurrence. D. Electron paramagnetic resonance. The answer is D. Electron paramagnetic resonance. 12. In ESR experiment, the magnetic component of the electromagnetic radiation that interact with the magnetic dipole associates with which type of electron? A. Paired electron. B. Unpaired electron. C. Two paired electron. D. Two unpaired electron. The answer is B. Unpaired electron. 13. The width of the octahedral ESR lines are fairly large, small, moderate, very large. The answer is A. Large. 14. In ESR, the spectrum usually recorded in which mode? Integrate mode, derivative mode, differentiation mode, multiply mode. The answer is B. Derivative mode. 15. As operating frequency increases, hyperfine splitting constant increases, decreases, remains constant, either increases or decreases. The answer is C. Remains constant. 16. In ESR, the kinetic energy term is due to the motion of electrons, protons, neutrons. The answer is A. Electrons. Number 17. The ESR spectrum is obtained by plotting A intensity vs frequency, B intensity vs wavelength, C intensity vs strength of magnetic field, D wavelength vs strength of magnetic field. The answer is C. Intensity vs strength of magnetic field. 18. Electron spin resonance involves detecting the detection of a physical phenomenon of electromagnetic radiation. A. Absorption. B. Absorption. C. Radiation. D. Reflection. The answer is A. Adsorption. 19. The patterns of the width of tetrahedral Cu2 complexes in electron spin resonance is small, large, intermediate, very weak. The answer is A, small. 20. Which of the following will not show electron spin resonance, ESR? A, free radicals, B, paramagnetic materials, C, transition metals, D, Zn2 complexes. The answer is D, Zn2 complexes. Number 21. Hyperfine splitting in ESR is observed due to surrounding A, paired electrons, B, unpaired electrons, C, nuclei with L equal 1/2, D, all of these. The answer is C. 22. Primary standard used in ESR is A, 1,1-diphenyl 2-biphenyl hydrazine, B, nitrosobenzene, C, tetramethylsilane, D, diphenyl hydrazine. The answer is A. Number 23. What is the wavelength range of the radiation used in EBR spectroscopy? A, X-ray, B, ultraviolet, C, infrared, D, microwave. The answer is D, microwave. Number 24. EBR is the resonant absorption of microwave radiation by paramagnetic system in the presence of A, electric field, B, magnetic field, C, both A and B, D, none of the above. The answer is B, magnetic field. Number 25. What causes the splitting of energy level in a magnetic field? A, Hund's rule, B, Zeeman effect, C, van der Waals interaction, D, Aufbau principle. The answer is B, Zeeman effect. Number 26. EBR spectroscopy is a direct and definitive technique for detection and quantification of the following: A, free radicals, B, paramagnetic species, C, both A and B, D, none of the above. The answer is C, both A and B. Number 27. What factor of a nucleus is directly related to the spectral line spacing and in the simplest cases is essentially the spacing itself? A, hyperfine splitting constant, B, atoms, C, magnetic moment, D, electrons paramagnetic resonance. The answer is A, hyperfine splitting constant. Number 28. The basic physical concepts of EPR are analogous to this measurement study, but it's electron spins that are excited instead of spins of atomic nuclei. A, magnetic moment, B, NMR spectroscopy, C, stable nuclide, D, nuclear magnetic resonance. The answer is D, nuclear magnetic resonance. Number 29. Which of the following is not true for an unpaired electron interacting only with a magnetic field? A, the energy differences between the two spin states increases linearly with increasing magnetic field strength. B, the energy levels are labeled by the projection of the electron spin on the direction of the magnetic field. C, the energy of the two spin states is equal when there is no applied magnetic field. D, the lower energy state occurs with the magnetic moment of the electron is aligned against the magnetic field. The answer is D. Number 30. Which of the following molecules cannot be studied by EBR? A, free radicals in the solid, liquid, or gaseous states. B, paramagnetic transition metals complexes. C, system with more than one unpaired electron. D, all of the above can be studied by EBR. The answer is D. Number 31. EBR spectroscopy can be carried out by A, varying the magnetic field and holding the frequency constant varying, B, the frequency and holding the magnetic field constant, C, none of the above, D, both of the above. The answer is D, both of the above. Thank you.